And the interesting thing about this is that we developed the handheld camera that you've just seen,
Right.
the virtual camera, as a response to cinematographers and directors who have a live action background who want to have a way of working within that space that builds on their experience.
Sure, sure.
In this case, we had people who have a gaming background,
Yeah.
and they wanted to be able to use a device like this to be able to control the camera. They didn't want to have to walk with a camera and do that,
Exactly.
that thing that a cinematographer would do. So we've developed the Xbox controller as an alternative way for people to control the camera.
Okay.
And it allows people who have that gaming background to be able to interact with the system in real time also.
Right.
And it also means that they don't have to do it within the motion capture volume. And that speaks to your question earlier. You were asking whether this could be recorded.
Right.
It definitely can be. And what often happens is that people will block the scene and record the actors, and they won't even have that virtual camera that we've just seen in there.
Right.
They come back the next day, they've selected the take they want. They can spend the whole day, a cinematographer and a director, just walking around with that virtual camera, and you don't even need the actors there because you've pre-recorded that whole 3D scene.
Perfect.
And the same thing here is that this scene could be recorded with the actors, and then you don't need the motion capture volume. You could have the director, cinematographer, gamer, whomever it might be, working just with the Xbox controller and recording the camera moves after the fact.
Right. And I noticed as you were moving in and out, you actually were taking a shot as if you were having the camera look through a window. Just as you were moving in and out, you were actually outside of the house or that virtual space and then looking in, which is completely different. I thought that was really interesting. Yeah. So it doesn't even have to be within the space. It could be exterior of the space, getting a completely different view. So Michael, I see you're doing most of the rendering work here, or at least all the technical stuff. So I know you're a part-time faculty member. Maybe you could kind of elaborate on that, what it is that you do and how you got into this, and maybe what some of the other aspects that we don't see behind the scenes are?
Yeah, it's Sheridan. I'm a part-time faculty for the gaming program there. So I have students that are learning game mechanics and various things to do with gaming and how to build games. And that ties in, they learn animation for how to use motion capture for video game systems.
Right, I hear a lot of students go, I want to get into gaming, get into gaming, get into gaming. I don't think they realize, usually when they're saying those words, how much work this truly is. It's not just sitting there playing games. I mean, this is a tremendous amount of work and a tremendous amount of theory, I'm sure. So maybe you want to touch on that a little bit.
Yeah, so when you get into gaming, it's no longer playing games, it's research and development. And when you're looking at all the things that go into a game, animation is one of the most immersive things that you see in a game. Sure. Your characters are animated, the people you play against are animated, right. Even elements in a scene are animated. So motion capture helps animators as part of their tool belt to get a template of what an animation should look like in a best case scenario for human animation or animal animation if we bring in, say, a dog or sort of a tiger in here to motion capture. It doesn't do things that are unbelievable like dragons with multiple heads.
Right.
So animators still need to do a lot of that work. Yeah. Motion capture also doesn't capture things that humans aren't necessarily able to do, like break their back 100 times falling down a building.
Right.
So we'll show the motion capture of the stunt performer moving into that action, and then it gets handed over to a physics system that would actually do the rest of the ragdoll animation for that.
Phenomenal. So now, what is the specific jobs of everyone that you have here? Because it's not just one person. There's many. I see a lot of people kind of hanging back in the back area here. I see your actor, and I'm sure everyone has proper technical names for it. So maybe you could tell us a little bit about that.
So with motion capture, we have a performance capture actor. In this case, one of our programming interns who's helping to work on code related to the Xbox camera controller and other projects that we're working on.
Wow, that's a big job.
Is volunteered nicely to be our performer for the day. We also have more programmers, CG artists that are responsible for creating the backgrounds here. Past interns have also contributed to parts of this set and various things in it as well. We also have them on the technical side, learning how to use all of this equipment, so both the art side and the programming side are learning how to use the motion capture. That's installing the system, calibrating it, setting up actors for shot days, also running demos like this when I'm not available so that they would interact with participants that want to learn about the system and how it works.
Sure, sure. Well, that's great. Well, thanks very much for elaborating on it. You kind of bring to light some of the background scenes that happen, so thank you.
You're very welcome.
Wow, that's phenomenal. So now, I know that you have a lot of other things that you're going to show us, probably something with the 3D camera that we'd like to look at, so that'd be great.
Great. Yes, we work in virtual production and performance capture, pre-visualization with motion capture.
Right, right.
But we also do a lot of work with stereoscopic 3D.
Right.
And that's a developing area for Ontario. It's being recognized as an area where Ontario companies and research centers are establishing a world-renowned expertise.
That's perfect.
We've recently, with York University, we've established a web portal called 3D Ontario, and that's really a knowledge dissemination site. It's a place where people internationally and locally can come to the site and can investigate what resources are available in different areas of 3D.
Right.
So any company, any individual who has an expertise in stereoscopic workflow or animation or as a cinematographer can put their profile up there.
Right.
And it allows for collaboration of groups from the province, but it also entices groups, productions from Hollywood or other places to come in here and use Ontario facilities.
Right.
But as part of the research that we're doing, we're doing a variety of things, and one of them is that we're working on different ways of shooting and of finishing 3D productions, both for lower end productions.
Right.
When I say lower end, I mean lower budget,
Right.
as well as for high budget. So in this case,
Yeah, this is a neat piece of gear here.
now this is a 3D camera rig, and what it does is it holds two cameras actually. So there's a camera up here that's shooting down,
Right.
and there's one on the side that you can see here,
see.
over on this side. So it's the two cameras, and there's a mirror that's used so that you have both images coming into the system, and they represent the different eyes. So one is the left eye and one is the right eye.
I see.
And that's what gives you the stereoscopic. That's what gives you that effect of having something in front of the screen and something behind the screen and something on the screen when you look at it in a theater. So this particular 3D rig is called the Tango rig, and it's been developed by a local company, Ontario company called LeFou Solutions.
Right.
And the earlier version of this has been used on various films, but it was also used for a production that we did when the Queen visited Ontario. We did a production which was a demo for the Queen and for the premiere of the expertise of
Right.
Ontario and the leading edge work that's being done in Ontario in stereoscopic 3D. And now what we've done is we've worked with LeFou Solutions to develop the next generation. So this is actually a prototype 3D camera rig that has refinements, and we've worked with them and evaluated and tested this rig, and it'll go into commercial production.
That's amazing. So everything that's happening right here isn't just all in theory. Quite often it gets really into the production field.
Yeah, I mean, that's the key to what we do here, is that there's research that takes place at universities, there's research that takes place at a variety of different centers. The research that colleges are dealing with really is focused on jobs, on income, on pushing things out into production, into industry.
Right.
I mean, our goals are to have students who come out of here who have cutting edge skills, who can work with companies on new technologies, new workflows, new processes, but also to identify technologies and adapt them, working with local companies so that they have a leading edge and can build their companies.
Well, being in IT, for many years myself, the problem is most people think that they need to, leave to Silicon Halton, or not Silicon Halton, leave to Silicon Valley. And we have a Silicon Halton area right here. I mean, the whole Halton region is kind of a great bed for bringing these students up into this type of environment. And I really think more companies need to be touted in the Halton region for sure.